Bună ziua, domnul Prunariu.
Mă auzi?
Da, vă aud.
Ok.
Hello, Heather.
Bună.
Mai așa.
Let me just check my audio. How do I sound?
I think it's okay. But I have an echo. I think I don't know exactly where is this from.
Okay, let me one moment. Let me check my audio.
Domnul Prunariu, dumneavoastră ne auziți ok?
Da, eu vă aud foarte bine. Nu știu cum mă văd.
Nu vă vedem, să știți că nu ați pornit camera. Ar trebui, lângă microfon, aveți acel buton pentru cameră.
Ok, da, corect.
I put two short presentation. I asked him to present, to prepare. I will ask you start first, and then in 2 minutes, 3 minutes, I will say something, and then of course I will let first Ravi and Erisa, and then of course Alexandru and Dorin to be the main guest of the conference. I will be more quiet just than usual. Okay.
So Mihai, are you doing?
Yes.
Hey.
Is that what I'm getting? Oh, look at your background. Beautiful. Good morning.
Hi.
Nice to see you.
You too.
Thank you.
How are you?
Here so early.
No, it's not so early.
Okay, so Erisa, we see you, but we don't hear you. Just unmute, please. Push the button, the microphone. Okay, good.
Yep.
Good to hear you.
Can you hear me now?
Yes, we are better.
Yes, we can.
I hadn't tried to talk yet. I was trying to get my headphones connected. Sorry.
It's fine. Just in time. Thank you very much for accept our invitation. I propose to start because we have 1 hour. I think, Mihai, we can do more than 1 hour if it's necessary. I don't know your time, if it's you need to stop at after 1 hour, or you can lay a few minutes more.
At 6:10, I shall have to leave because I shall have to transmit in a TV station. So 6:10, okay?
Okay, Mihai, just push and start. We are here from the last century. We are here for almost 2,000 years. Atlantykron 2020. New horizons. afternoon, good morning. We are Atlantykron. Thank you for joining us this afternoon and of course morning in the United States. I'm happy to introduce our special guest this afternoon, our friends from NASA. Thank you, Erisa, Stilley, join us. Thank you, Ravi, Prakash, and of course, our Romanian very special people, Mr. Prunariu and father of Atlantykron, Mr. Alexander Mironov. Also, I'm with my team, Gabi Bursan and Mihai Oprea, and another two juniors which were invited because they have something special which is related to the space. Heather, please. Heather, unmute. Okay.
I'm unmuted. It always helps when you unmute. It's a new world with Zoom. We have to remember to unmute. That's one of our staples of learning. But good morning, good evening to everybody. Welcome everybody that's watching us live on Facebook. It's wonderful to be here. We've been looking forward to this. And thank you, Erisa and Ravi, for joining us once again, where we're all virtual this time, for this year's 31st year of Atlantykron Summer Academy. And we're especially excited because just a few days to go, we had a very special launch, and we've been very lucky to have you here for the second time, soon after one of these amazing launches that you have. So welcome and thank you for joining us with all our youth to help inspire us for our future and help us learn about where that future will be in space exploration. Welcome.
Mr. Prunariu.
Hello, good afternoon and good evening to all of you. I'm very glad to take part in this very interesting panel about space exploration. Mars is far away, but not so far. Moon is right here, near to us. And in the next years, we'll see tremendous events happening in outer space.
Thank you. Mr. Mironov.
Hello, everybody. I'm very glad to see all of you in a place where we had dreams about flying up to the cosmos. I can imagine, Prunariu being the admiral of the fleet of 3 rockets flying now far away to Mars. It has happened during our lives, and it is only the beginning. The fact that this pandemic mixed together with the progress made in technologies of science, of space, are a good omen. I think it's a good omen. Welcome to all of you, and I'm very glad that the idea we had in our brains, Sorin, Aurel Carachel, and myself, some 30 years ago, is now simply getting some reality. I've already thought about Atlantykron as an island of stone that one day will fly up in the sky.
Thank you, Mr. Mironov. And now I ask you, dear guests, Ravi and Erisa, just take the lead and take us as you propose in the universe of NASA.
Great, thank you. Thanks to everyone for having us. Erisa and I are super excited to be chatting with you all today. We do talks to lots of different groups, and ever since I talked with this group shortly after the Curiosity rover landed on Mars, it's been my favorite talk every year, and I always look forward to talking with you all. One of the reasons is because we get really great questions every year, and we encourage questions, so please feel free to chat your questions throughout. And we also get great ideas from you guys. We know that this year there's more than 400 of you and about 30 different countries represented, which is just blows my mind. And so I love the diversity of this group. Before we start, I know many of you told us your favorite planet. I love that every planet, including Pluto, got a vote, even though Pluto was demoted. And more than half of you said the same planet. So maybe everyone take a minute and think real quick which planet you think got the most votes. I'll pause. It was Earth. Funny, right? So It had about 4 times as many votes as the second place planet, which was Saturn. Saturn had about 14% of the vote, followed by Mars, which had about 8%. And then, you know, the rest followed after that.
I was surprised.
Yeah, isn't that, you
I
know,
was really surprised.
usually you expect maybe to hear about other planets, but I'm kind of glad that Earth was so popular. It's, you know, it's our home. The only planet that we have.
I did notice also that both Ravi and I haven't taken in everyone else's backgrounds, but both Ravi and I selected something that we're familiar with here on Earth as opposed to something otherworldly. So I was in, yeah.
It was great.
Yeah, whether or not you know it, what we know about most of the planets in our solar system is thanks to the place where Erisa and I work, which is NASA's Jet Propulsion Laboratory. It's a NASA center in Pasadena, California. Some of you may have heard of it. Many of you may have not. And so we do focus here on robotic exploration as opposed to the human side of exploration. And here's a little video that's going to tell you a little bit more about what we do here. I'm going to unplug my headphones so that you get the audio.
What does JPL do? It's the most unique place to work on Earth. Our charter is to do things no one's done before. We do what no one else even does to dream about. Imagination and innovation are crucial in being able to do the kind of work that we do. Innovation comes from people, but it also, I think, comes from structure and from the environment. If you can provide people with the appropriate tools, the appropriate workspace, the appropriate environment, you're also going to get a higher innovation output. One of the things that makes the JPL environment so special to work in is that even when you first walk on lab, it feels like a campus. When you walk around, you hear people talking about their work. What would be the best way to get a subsurface vehicle beneath the ice of the open? Because those people aren't just talking about it because they saw it on a movie somewhere. It's because they're really trying to figure out how to do it. JPL is an incredibly diverse place. There's thousands of people here with big brains. Planetary science, answering these big questions, you chemists, physicists, astrophysicists, biologists, and then you need everyone on the engineering side to actually build the things that you need to answer the questions. People know so much about so many different things that if I'm looking for an expert in a particular field, engineering or science related, I can probably find them at JPL. I don't have to pick up the phone, I don't have to walk down the hallway. Science is all about asking questions, and engineering is all about finding solutions. And so it makes sense to marry these two things together and try and answer the biggest, toughest, most difficult questions we can come up with. What does JPL do? JPL builds the tools for exploring space. The boldness of my colleagues is inspirational. The scope of the questions that they want to answer and the courage with which they go about tackling these big questions. People try the enthusiasm and the intelligence, the intellect that people throw every day at every problem that comes across. Given a very challenging problem, please do this thing that's never been done before, that you don't know what to expect, that there's a huge uncertainty involved with. Most people would be terrified by that problem. I think those are the problems that we salivate over. We shouldn't do something because it's safe and easy. We shouldn't do the thing that everybody knows how to do. We should push the boundary, and even if that means we might fail, we might succeed too. I've never met anybody here that says, well, it's too hard. We all sit down and we just start crunching the numbers and figuring out how to get it done. It's a journey. It's not necessarily an end destination. It's the whole way to getting there. It's a very liberating kind of environment to be in because you don't have to be so afraid of mistakes. To recognize that we're doing science inside the solar system, outside the solar system, science focused back on Earth. Our missions have a goal of helping humans understand more about the universe, and I think that's pretty amazing. JPL has enormous respect for a good idea, and if you have a good idea, this is the place to bring it to fruition. JPL is a special place because it allows people to have careers that are only limited by their imagination. Well, there certainly is this drive, I think, from human rights to go explore, and not everybody's involved directly with that effort. As the years go by when you're at JPL, it becomes very clear that it truly is a privilege to be here.
This lab is a legacy for not just this country, but for the world. And someday, if we ever do find that exoplanet that has life on it, or has some other solar system outside of ours, this is a place that's going to do that.
Bravo.
I apologize if the audio didn't come out. We're going to provide that link to Heather in the group, and maybe they can email it out at some point.
Definitely. Yeah, we'll put it
The
in.
pictures say a lot. You are a great team over there.
Thank you. Thanks so much. Erisa and I are both super, super lucky to be working at JPL. We do realize that all the time. It really is, as the video mentioned, a really cool place with a lot of creative people and fun people and people with really big brains, as they said. We wanted to share a little bit about who we are. Before I do, I want everyone to think a little bit about what it is that you would want to do as an adult if money was no object. So think about it. Don't pretend, salary doesn't matter. What would you do that would make you super happy? So for me, I didn't know that I wanted to do this work until pretty late in my, in my younger life. My whole life, I wanted to be a doctor, and it wasn't until senior year of high school, my last year before college, that I realized I don't want to be a doctor. I didn't know what I want to do. So I went to business school, and I realized at that point that I really missed math and science. And so I could not have told you at that point what an engineer is. I really didn't know. But I knew I wanted to be an astronaut. And so I looked up a lot of astronaut biographies, and I saw that a lot of them were aerospace engineers. And so I thought, okay, it would be cool to build spaceships. So I changed my major from business to aerospace engineering, which at the time felt like a really big deal because it meant I had to go to an extra year of school to make up for all the missed classes that I would have had when I was in business school. And it felt like a really big decision, but it ended up being the best decision I could have made. I'm really, really happy now. And so I'll just talk a little bit about what I've been able to do at my time at JPL. This picture on the top left is me next to a test model of the Curiosity rover. This is the model that we use just to test on. We tested before we launched the rover, and we still use it today to test before we do things on the rover that are unique or first time activities. The bottom left picture is me in mission control during our cruise to Mars with the Curiosity rover. We were testing out some instrument sensors that are on the heat shield, the part that protects us from burning up on the spacecraft. Going counterclockwise, the bottom right picture is me next to a test model of the InSight lander. This lander landed on Mars just after Thanksgiving, or I guess late November 2 years ago. And this one is trying to understand how did Mars form as a planet, and will help us understand how Earth might have formed as a planet. And then the top right picture is me with my family on the day that we landed on Mars with the InSight lander, my two daughters and my wife. Now I'm going to hand it over to Erisa.
Hello, Ravi, thanks for such a great introduction. It's great to see you all. Great to be with you again this year. And as Heather said at the start, we've had a pretty exciting couple of days that just passed. So I'm happy to talk a little bit about that with you guys. First, I'll give a little bit of an introduction for myself as well. So I've been at JPL for 14 years now, which can feel like sounds like a long time as I get older. But just a quick history, I grew up in Missouri, which is the state that's highlighted in red there on the map of the US, since it's not a common state that many people know internationally. I went to school in Southern Florida for a bachelor's in mechanical and aerospace engineering, and then did my master's degree at MIT, or the Massachusetts Institute of Technology in Cambridge, Massachusetts. And that's actually where I learned that JPL even existed. Before I went to college, I originally was thinking about considering doing a veterinarian degree, doing marine biology. That's actually what got me to look at schools initially in Southern Florida and some other places in the US. And it wasn't until I was sort of alerted to my desire for just my strong, I guess, inclination in math and science that I, through a conversation with my parents, they talked to me about considering engineering. And we didn't really have an opportunity to learn what engineering was when I was in high school, at least at the school that I went to. So that sort of caused me to pause for a second and think about the pros and cons, or like the difference in choosing something like marine biology or engineering. And I ultimately decided engineering might be a more flexible choice in terms of where I could live and work in the future. So that's what I ended up studying in school. And then through the series of school and my advisors and then grad school, learned about JPL. So I got to do an internship as I finished up my master's thesis. Really liked it as an organization to work with. And I took a year off to explore the intersection of what I had learned in school with my faith, and then ultimately came back to JPL full-time a year later. Some of the images you see are really focused on my time on the previous Mars mission, previous Rover mission, Curiosity, where I helped with the cruise operations and getting the vehicle ready for launch ahead of the surface mission. And once we had landed on the surface, I then transitioned to working with the test team for the rover. And then once I had the chance to learn how the rover operated, had the chance to do rover operations. So I've gotten to see both the crew, what we're doing now with Perseverance and flying it to Mars, as well as how it works once we're on the surface. So it's been kind of an exciting long duration now for me in the Mars community. Prior to that, I worked on a couple of other projects at JPL that were related to returning humans to the moon as part of a lunar lander study, and working on a mission called Dawn, which is now retired, but it was a mission that studied Vesta and Ceres in the asteroid belt. So we'll there's obviously so much we could talk to you guys about, and we want to make sure we leave plenty of time for you all to ask us questions. Sorry, Heather, did you want to say anything?
No, I was said, yeah, we could sit here for hours, but I think you probably have a busy schedule. So,
right. So
I'll be here all day.
So I'm going to try and hit highlights, but I'm happy to answer. We're happy to answer more questions on the back end if there's specific things people want to come back to, or if people want to put questions in the chat as we go. If someone else can moderate that, we can take a pause and answer a question.
Okay, Mr. Prunariu.
Oh, hello once again. So actually, I flew into space 39 years ago in 1981 on board Soyuz 40 and Salyut 6 space station. Accomplished an 8-day space flight and I accomplished a lot of scientific experiments on behalf of Romania. But now, after many, many years, having a very wide experience in space activities, being involved in a lot of organizations, missions. I mean, Romania is a full member of ESA and work together to all important projects of ESA. We are now focused on the exploration of Moon and Mars. And as long as the new probe was launched a few days ago, 30th of July, Perseverance, I want to mark a little bit what is the interest of the human community on Mars. I mean, Mars, it's a planet very close to the Earth. I mean, some processes happened on Mars many, many years ago, millions of years ago, like they happen on the Earth. It's my belief. It's my personal belief. Now we try to explore and to find out life, if it's possible, biological life on Mars. Only this year, they were already launched 3 missions to Mars. Is the Hope Mars mission by the United Arab Emirates, launched on 19th of July. Is designated to study the atmosphere of the planet. Is the Chinese mission, Tianwen-1, launched on 23rd of July. This mission will have an orbiter, a lander, and a rover, and tries to find out also some probes for demonstrating the former life on Mars. Of course, the Perseverance was one of the most complex missions, having including in the all experiment and helicopter, will try to fly in the very rare atmosphere of Mars. Also, another mission was planned, but it's delayed now, the ExoMars mission of ESA, together with Roscosmos. It is postponed for 2022, and it was supposed to launch a landing platform named Kazachok, which is expected to carry the Rosalind Franklin rover, and also another mission planned by India. India always send a mission to Mars. This is the second mission, Mars Orbiter Mission 2. It's planned to launch in 2024. With all these missions, information gathered on Mars, we try to prepare very well a human mission of Mars, on Mars. According to my studies and beliefs, maybe a human mission to Mars could happen to the end of 2030 years. I mean, 2038, 2039 maybe. But the next missions on the moon, in the framework of the Artemis program, which will put on the moon in 2024 the first woman and the next man, are meant to prepare a more complex flight to another planet, to Mars. If a flight to the moon takes about 3 days, to Mars it takes about 7 months. It's much more complex. The planetary environment, it's different. The space radiation could influence a lot the human activity. And we have to take all measures, active and passive measures, to protect the humans in the next flights to Mars. Thank you. If there are questions, of course, I'd be glad to answer.
Yeah, that was a great summary. We put together a couple, as we kind of flipped through when you did that, a couple of pictures from the UAE and the Chinese launch, but I did not capture all of the other planned launches by other countries that haven't happened yet. So thank you very much for summarizing that.
Okay, thank you, Erisa.
Any other additional information regarding this mission, or something what is good to share from the last few days when you have the launch of the rover or the landing of the crew from space?
Oh, of course, we have many space events this year, and including this month. So the crew of the NASA crew sent into space by SpaceX, by Elon Musk, just landed safely. It's a big success. The first American crew using an American private spacecraft flew to the International Space Station and returned safely back. Of course, this is a big success, and it's a new beginning because the private institutions, the private companies are very interested to fly into space, to make profit if possible, to bring resources from the moon, from asteroids, and to develop as much as possible these activities. In any case, I congratulate the space crew of Demo 2 mission of SpaceX for their successful landing. They are our colleagues. We all are members of the Association of Space Explorers. It's a big association of more than 400 people flown into space. And I used to be, for a period of time, the president of this association from 2011 to 2014. Soichi Noguchi, who is included in the next crew of SpaceX, the head of the Japanese astronaut team was the next president of the Association of Space Explorers after I concluded my chairmanship. And we are very good friends, and I really wait with big interest the new SpaceX flights, this time with 4 astronauts.
Let us put things in order, Sorin. I mean, we are now assisting of a contest run by robots, Earth robots going to Mars. You know, it's an armada of robots going over there, joining others that are turning around Mars or are working on its surface. So we are still far away from the very moment when the next Prunariu will put, the next Neil Armstrong will put his solo on Mars. But something is happening around Earth. So in low orbit, for me, the International Space Center is in low orbit. We have 3 people working over there. They live there. So we Earthlings are up there above Earth and looking at Earth. So these 2 different moments have to be looked after differently. And I have to put something in addition, something that Prunariu always underlines. It's not only Americans, it's not only Chinese, it is not only Arabs that sent these robots. It's the whole Earth doing that. It is the whole society. People from all countries, that fanatics that love to be up there in the sky, love to be somewhere in the solar system, are now pushing things together. Nabi and Erisa, you may know that you have a colleague called Dan Bartolomeu. Dan Bartolomeu is working on the rover that is now on its way to Mars. So it's everybody, all countries are going there. Sometime in the future, you know, I dare say that maybe if we have this talk 100 years later, we shall speak differently, of course.
Thank you.
So,
every year,
I just to point out that space without international cooperation, it's impossible to do.
That's right.
International cooperation, it's very important that this international cooperation in the peaceful use of outer space just unite the nations and make them more peaceful.
Yes.
Erisa and Ravi, every year you share with us some interesting things from your work. With other words, have you something to share this year regarding the last rover was sent to Mars, or another thing from your latest work?
Yeah, so I mean, the biggest thing that I've been focused on personally is related to the Perseverance mission. So as you guys have noted, we had a very successful launch a couple of days ago. And now the cruise operations team is getting their feet wet in, they've had a couple of anomalies with the spacecraft that you can read about on the internet. And they're learning, being reminded that it really is a spacecraft seeing space for the first time. And so you work through any initial differences in what you've modeled on the ground. And so they've done a great job so far of working through the issues that have come up since we went live on the way to Mars, and getting it ready for the first big trajectory correction maneuver that is normally planned about 15 days after launch. So they're very busy right now. I'm on the landing team this time around, the entry, descent, and landing team. So my lead for that team reminded us once we had the successful launch that we have 200, now down to I think 200 or 199 days before landing. So we have a lot of work to finish before that happens. So that's sort of my focus and the marching orders that I have. I know Ravi, I think, is going to talk a little bit more about his mission coming up. So let's flip through a couple of these slides just to get to that point.
Great.
So we've talked in the past about, and I should say that the plan is for Perseverance to land February 18th, 2021. So mark your calendars for that. It's a fixed arrival date, so that's when we'll be there. You can look at these pictures and the rovers look pretty similar, but there are some notable differences. One of the things, I'll just highlight one of the things I am most excited about is we have cameras this time around on the rover during landing that we're hoping will give us images of deploying the parachute and of us landing the rover, similar to what we did last time, but many more cameras and in different places. So we may have some really interesting imagery for the public this time around for the landing. The other thing that's very different about the new rover, Perseverance, is it has a coring drill. And the intent is for this to be the first step in Mars sample return, which I know many of you are familiar with. So this rover will take samples from below the surface, store them in hermetically sealed tubes, and then the plan is to send a pair of future missions in conjunction with ESA and other organizations to bring those samples back to Earth. And I think it's on like an 11-year horizon or so.
What is the contribution of Department of Energy for this rover, Erisa?
This rover does have a nuclear power source called an MMRTG. And that's what supplies, I think, about 100 to 115 watts at a time, constant for the rover. So that's what charges the batteries up at night. You won't find any solar panels on this rover.
Which is good, right? It's a perfect from the mission.
It's what?
It's a perfect from the mission of the rover, having power all the time.
Yeah, so we can select either solar or nuclear. It's one of the first trades that a team will do when they're designing a new concept based on what that vehicle's needs are. So the InSight lander that Ravi mentioned is a solar powered lander. And he can probably speak more to why that was the right trade. Having the nuclear source allows us, depending on where you go on Mars, to ride out seasonal variations with a little more robustness. And it means that we're less susceptible to dust changing how efficient those panels are. But it also means it's a very slow draw, right? 100 watts isn't a lot of power when you think about it. So it's sort of the slow drip of power that does limit how much we can do every day. The last thing I wanted to say here is just something people get really excited about is the fact that we've also flown a helicopter as part of this mission. So there is a small 1.8 kilogram helicopter called Ingenuity. It's stored underneath the belly of the rover and has a cover on it that you can't see in this picture. And so the idea is after we land, we'll deploy that cover and deploy the helicopter. And it'll be with us, I think only the first 30 sols or so is what they're planning, because it's really just a technology demonstration for us to actually show aerial capability in an atmosphere that's only 1% that of Earth. And assuming that it goes well, then that's sort of a neat bonus that that some people with the ability to make those kinds of decisions were able to be part of this mission. So that's exciting. Ravi, do you want to go? Yeah. So in terms of, we wanted to talk a little bit about future missions, and Ravi will take us through most of that, but I'll start by just, I've already said that we plan to bring back these samples from Mars that Perseverance is going to seek out and store for us. So this is a concept of the Mars Ascent Vehicle bringing those samples back into Mars orbit, where they can be transferred to a vehicle that then is capable of bringing them back and landing them safely on Earth. Ravi, do you want to take it?
Yeah, I just wanted to bring up, Dorn already mentioned that, we're going back to the moon, and that's super, super exciting. This is just a cool picture of, what it might look like when we are on the moon permanently. But what's cool is that, we've sent, we sent men to the moon, and now the first woman is going to go to the moon. And that's really, I think, exciting to pave the way there. And that just leads us to eventually going to Mars. We've only set foot on Earth and the moon, and, wouldn't it be great to expand that boundary and go to the next place, which is for us Mars. But we don't stop there. We continue to dream beyond that to even more ambitious new horizons. Like what if we lived on other planets like Jupiter or Europa, which is a moon of Jupiter? What if we lived on other Earth-like planets outside our solar system or outside the galaxy? JPL created these fun little travel posters that imagine what it might look like to be on these other planets. And it's because we're not afraid to dream big. Who knows, like these seemingly fictional ideas might become someone's future reality. And so it's important for us to not be afraid to dream something which seems so far out right now of like living on these other planets. So speaking of making futuristic missions a reality, JPL has this team called Team X. Team X celebrates its 25th anniversary this year. It's a place where dreams get closer to reality. So it's an advanced design team at JPL that, in just a day or two, they rapidly create a mission concept. So someone says, I want to go to, let's say, I want to go to Titan, and I have this much money to do it, and I want to understand, are there methane lakes? So I have a science objective, I have some sort of amount of money that I can spend. And then JPL gets a team of experts across the entire lab. You get someone that's really an expert in maybe the power system and the thermal system. And if you're landing, you need an energy descent landing engineer like Erisa. And you get all these people in there. And the goal is to say, in a day or two, let's design this out. And it's not going to be, a final design, but it's going to be a great starting point for that person to go and advance that design to the next stage. And so this is a really, I think, cool place. I've happened to sit in on these sessions where it's great to see these experts just, talking and figuring out how to make this work, because these are really, really hard missions to make work. I'm going to pass it over to Erisa again.
Yeah, so one of the other things that has been a big topic lately that we wanted to make sure we at least spend a minute or two engaging with you all as other panelists and big thinkers is just the change in the recognition of diversity and how important that is to organizations. I think it's been pretty well studied and shown that that the diverse, having a diverse set of thinking, we think about recruiting from different universities, and if we're always getting the best people, so to speak, from the same 3 universities, do we really have a diversity of thought that's going to bring together the best set of ideas that we could possibly come up with? Because a lot of places have their own culture, they have their own way of doing things. And so as we can expand that diversity, whether it's cultures, ways of thinking, just the backgrounds that people have, it strengthens our organizations. It makes us, I think, smarter and more able to serve the people that we're exploring for. So this is a photo that I got taken at JPL with women that work at JPL. It was like Women's Day, International Women's Day, I think. And so it was just a nice way to remind us to kind of have, to think about how to change, bring more diversity into our organizations.
Okay. Anything else, or this is the last picture you have on presentation?
Yeah, we're ready for questions.
Okay, before that, yes.
I wanted to add one more thought. When we were speaking a bit about just commercialization and helping to sort of push us as we continue exploring both lunar, at the moon, and at Mars. I have been very excited. I worry sometimes, right? The International Space Station has been such a great part of our low Earth orbit presence, and it often is one of the things that, because of its age, we talk about defunding. And some of you may be aware that Tom Cruise has established a partnership with NASA and possibly other organizations to, for the first time, film a movie from the International Space Station. And that I got excited, one, because I'm a fan of Tom Cruise and I enjoy his movies, but also because it's a way that we maybe commercially are going to be able to provide funding for something that, has been difficult to continue paying for. So it's just another way that I think expanding our ability to use commercial sources of funding can help us in our space exploration.
If there is an element of culture that I should advise to everybody to pick it up, it's a novel, a beautiful novel written by Kim Stanley Robinson. red Mars, green Mars, blue Mars, which is something that if I were in GPL, I would send to all schools on Earth. Let kids have it, read it, and get accustomed to the idea that, you know, the mob, the wonderful mob you have here, may even run not only the world, but the whole solar system. I think that someone like Prunariu is just the man that could show better than Tom Cruise and anybody else.
That's right.
That we can run the world. You can run the world. You are very well suited for that.
Mr. Prunariu, do you have any questions from our friends from NASA?
So actually, I want to answer to Alec. So we need dreamers. We need people who dream about space, who have imagination. And then we need practical things to do with practical people. Like, I tell you openly, I admire very much Elon Musk. And I see he was a dreamer, and now he flies to the moon very soon. Questions? No technical questions, because I have a lot of information and I know what will happen in the future. But a question, just generic question. What do you think, how people will live on Mars and for how long? So actually, because I pointed out Elon Musk, he said that in 40 to 100 years from now, we'll have a colony of about 1 million people on Mars. So the Mars gravitation is much less than the Earth, 2.5 less. So the muscles will develop in a different way, the bones and so on. You have to produce oxygen to live in an artificial atmosphere inside, to be protected by radiation, by micrometeorites, to live under the cover of soil, Mars soil and so on. How do you think people will live so long on Mars? And what do you think about the psychology of such people on the long term?
I can take a stab at it. I don't think about it maybe that often. I'm not the best dreamer or visionary. I'm more of the get down to business and get it done. But I think the questions you ask are very important. I do worry about the psychology. I think a lot of people that imagine going and spending that time, I have a hard time imagining myself living for so long on a place that seems so less colorful, maybe is a way to put it, than Earth. And so I do think the psychology of it, you know, is very important and could be very difficult. As you mentioned too, the time it takes to get there is not short. You know, it's 7 or 8 months for robotic missions, but my understanding is that it's a longer flight for humans because we can't enter at the same high velocity that we do for robotic missions. And so I think it could be more like a year and a half for that flight. You don't want to spend a month or two, which is long compared to the time we've spent on the moon, and turn around and come back. So I think that we'll learn a lot based on the lunar exploration, because it's easier to return home if things start to go south. I have a hard time imagining our expansion on Mars until we've learned quite a bit on the moon. That's me personally. I know that there are other people with great visions for Mars and have already thought, you know, into that space of 1 million people and what that would look like. I think we're going to green it up quite a bit to sort of satisfy our need, you know, for things that can grow and thrive, whether it's for food source or just because we enjoy looking at pretty things that are alive.
Yeah.
Yeah, I'll just add that I think the entire, you know, it does sound like a long time to get to Mars, but when you think about it in the context of human exploration, people would spend, you know, many months on the ocean to explore new places. And, you know, Seward, I think his name was, explored Antarctica, and, you know, people don't know if they're coming back or not. And so the human spirit is just amazing that there are the types of people that will do this type of exploration and do whatever it takes to be the first to see a new place.
Point.
Okay, because Mr. Prunariu mentioned that we need to have what, sir? We need to have teenagers who dream, right? Because Elon Musk has a dream, and now he's almost in the top of his dream. Okay, we have two students here, Paul Parascheva and Radu Chaka, I will ask Paul quickly in 1 minute to talk about your projects, right? Paul? And then you have one questions per person. Paul and Radu, prepare to ask a question for the panels here.
Well, hello there. My name is Paraskiv Paul. I'm a student at University of Polytechnica in Bucharest. I'm in a team at the moment that works on making a 3D printer that will print in microgravity. We are currently working on a project made by ESA, Rexus Bexus, if you heard about it. Well, I do have a few questions here about
you is too much sometimes.
Yeah,
I'm sorry I wasn't able to keep up with everything in chat, but I was trying to read them and possibly
okay. Good. Technical question about the helicopter. How it will fly on the Mars atmosphere?
So it has two very long rotors that it uses essentially. So the way that it will fly is the same way you would imagine it flying here. It's just that because of the limited atmosphere, they had to create very long, very efficient rotors and a very light vehicle. So the mass that they were constrained to was very small. They also, because this was sort of a ride-along project with the rover, we had to constrain them in terms of how big, in terms of volume they could take up, because it needed to fit within whatever we could package the rover. It needed to fit in whatever space we could give it because of the rover size itself. So, you know, that's why I call it, that's why we've called it a technology demonstration. In the future, an example of maybe a different craft is Dragonfly, right? Which is a future mission to Titan. Titan's atmosphere is very different. So Dragonfly is a very heavy, large, I think it's larger than Perseverance. Like, it's a very large flying vehicle. It can land, take surface samples, and then fly and go to a next location. So it's a very different environment than Mars. This is really, after a lot of hard work by a very small team at JPL and doing some Martian atmosphere, you know, in a vacuum chamber testing at JPL, they believe they were able to build a vehicle that can fly, but it has to be very lightweight. There's a really good video. It's linked in the presentation, and I didn't want to take the time to show it. But there's a good animation video that sort of shows how it gets deployed and flies. But the mechanism for how it flies is similar to what it would be at Earth. It just had to be a much different ratio of mass to lift.
Okay, before go to Radu for the questions, let me tell you one question from the people who watching us, Mr. Constantin Ferseta. If we will find life on Mars, dead or alive, are you going to report immediately that discovery to the global press, or you need to go through some censorship commission before, as ethical, religious, etc.?
I can just take a quick gander at that. So, finding life on another planet, first of all, is just very, very hard to confirm. The types of instruments we send to Mars or other planets, they can tell us that there have been maybe signs of life in the past, or that, what Curiosity did was tell us that Mars, has the chemistry to support life. But it's hard to say that without a doubt that there is life. But let's say we send humans somewhere, and maybe, they can do so much more than robots can, and they can confirm something. I think because of the profound implications of this, I think the first thing we do is, inform the President of the United States. And the politicians, unfortunately, decide what to do with the information. But, you can't keep a secret like that for, that's going to get around, NASA pretty fast. And so I think without a doubt, whatever the politicians decide, it would get around, is my take.
I would also add that we have the scientific community in particular is extremely international for any of these missions. And so I think that before there's any, back to similar to what Ravi said about just the difficulty in confirming, there would be a lot of, I think, scientific weigh-in from around the world before before you would get sort of this confirmation that we all agree that that's what has happened. Perseverance is similar to our past robotic missions in that I don't think Perseverance, unless you caught something in an image or a camera that was just undeniable, right? There isn't anything that I think we'll be able to do on the surface to directly confirm even past life. The idea of bringing these core samples back is that we have technology here on Earth that is so hard to miniaturize and power on another planet that we can study things much more easily here on Earth. The thing that Curiosity and Perseverance and these past missions have been able to do for us is create the context and sort of build the story of whether or not we think it's possible life had existed previously. Well, now we want to take core samples and see if we can identify, Jezero Crater, which is the landing site for Perseverance, was chosen because of the belief that historically it was a lake, and that it had filled up with water and dried out at least three times over 3.5 billion years. And so they've connected finding 3.5 billion year old rocks and structures in a location in Australia with this life cycle on Mars that has sort of frozen in time compared to Earth because it's, it's more quiet tectonically. It's been radiated over time with the loss of the atmosphere. And so that's a big part of the storytelling on the science side that says why we want to go to Jezero Crater and why it's important to get these samples below the surface. Because if anything was there in the past, we hope that it's been preserved below the surface and that we're able to bring back those layers in a way that we can actually study them here and try and look for those structures that we can then tie to a biological presence as opposed to just geological or otherwise.
Thank you, Erisa. Radu, short question, not few, just short one. Not I would.
We can't hear you.
I think is it Paul? You had one more question.
Radu's trying to talk, but we don't hear his audio.
Oh, I'm sorry.
Is the microphone off?
I think he's muted.
Unmute the microphone.
There he is.
Mr. Mironov, let's have a question or a challenge for our friends from NASA.
First of all, I want someone here near me to ask a question. Please do.
Yes. Hello. I wanted to ask because you've mentioned Titan, which
No.
Europa is.
Speak on the microphone.
I wanted to ask a question regarding Europa because you've mentioned Titan, the moon Europa, and that is how exactly would you go hypothetically about exploring it? You would use submarines, right? I imagine, but the problem with that is we don't really know much about our own oceans. We know more about space than we do about our own oceans, and so the technology involving submarines is very behind what it should be. So I imagine on Europa, if we were to use the exact same technology as we have here on Earth to make submarines, we would never survive the pressure.
Oh, that was the question.
So are you asking specifically about human exploration of Europa?
Yes.
Well, even if it's not human, even if it's made with drones or something, we still need a material or a technique. So
Speak on the microphone, please.
we still need something to get past the high pressure of the water. So it doesn't really matter if we go with humans or with just robots or drones. It's still a problem.
Yeah, so I think we do actually know a bit about our oceans. There's, it is big, so it is hard, it is a continued area that humans are exploring. I think it's the same, it's the same physics that would drive exploration under our oceans as it would exploration under Europa's oceans. It's still, water, assuming that I think it's water. So, water is water. And we know how to build a pressure vessel that would go under the ocean and do some exploration. Now, you might not do everything on this first mission, right? It's always just like the first rover that we sent to Mars was really, really small. It's the size of the wheel on the Perseverance rover. And we didn't know a lot about the Martian surface. We didn't know what kind of wheels we would need. So we had to err on the side of building, you know, maybe wider wheels to withstand the pressure. It's the same sort of idea with exploring any new place, is that the first time you don't know a lot, so you have to be very cautious in your approach. And so the design of anything that we do that would go into the ocean of Europa would just be maybe more cautious than something that would happen the next time, the time after that, and the time after that. And every time you're going to learn something more about what is under that ocean. It's a really good question.
Thank you, Ravi.
Yeah.
One of the reasons we're interested in Europa as well is, again, because of the search for life. And so the other thing that we spend a lot of time having to engineer our way out of is not destroying the thing that we're coming to study. And so there's a lot of time, effort, money spent in thinking about how do we not bring life with us and drop it off, as opposed to being able to discover it. So that's actually one of the bigger challenges of Europa.
Thank you for
there are several, but that's one.
thank you for answering. Now I think Radu has a chance to find the unmute button.
Okay, can you hear me now?
Yay.
Good.
Great.
He wants to fly to the space, but it was difficult to find the button. But look, it's a perseverance, right?
Yes. Okay, so I go straight with my question.
Before Radu, why are you here? Because you're part of the team with Paul. And what you want to do? Say again. You want to build a printer. Who wants to do what?
Okay, so I'm one of the Paul colleagues. What we are going to do, we are going to build a 3D printer that uses a kind of new technology using resin, UV resin. It's quite popular already on Earth. And our project will be launched inside a sounding rocket by the European Space Agency and by the German Aerospace Center, and also by the Swedish Space Agency in March next year in a suborbital flight. So this is what we are trying to do, and also we are trying to build and to grow a space community with young students that are interested in space technologies. So now my question, as you know, many space platforms have already started to be more accessible to university and high school students. I'm talking about parabolic flights. Even high school students have access to do experiments on ISS or parabolic flights like we are trying to do. And my question is, if you think that rovers on Mars or other robots will also become a platform accessible for research, student projects, or for educational purposes. That will be my question, because mainly in order to do so and to give access to students, more experienced engineers have to create some interfaces beforehand and to let us in.
I believe the reason some of the other things you mentioned have become available is because the cost for those things has become so much lower over time. One of the things they did talk about, in addition to what you mentioned, both for the InSight launch and then again for the Mars 2020 launch that didn't come to fruition, was if we have extra mass available because our payload didn't take up the full launch vehicle mass, can we add CubeSats that are student or low cost to other organizations? It doesn't have to be university or student. Can we just offer those as payloads, payload space that's cheap essentially for CubeSats? As those have become such a strong platform, a low-cost platform for different experiments and studies. Neither of those came to fruition for our projects, and I don't know if that's because like you said, the interfaces weren't clearly defined. It was too late to give that opportunity to people. So I think your question about the rovers is a great one. I think it's a good question to ask because it gets people thinking about it or starting that conversation. If it isn't on, the people that get to make those decisions, if they're not thinking about that. But I think because the cost of sending a rover, at least to Mars right now and to other planets, is still considered to be fairly expensive, that unless it was similar to our helicopter, unless you could send a payload that was completely self-sufficient, you could think about like the Marco CubeSats that were part of the communications for the InSight lander. Those were separate payloads, and they were, they were a separate project under JPL and NASA. but they were essentially a ride-along that was that brought value to the InSight mission, because it gave us more ability to do communications during landing, and then they continued on their way. So it's possible if you could build something that was self-sustaining as a CubeSat, that would more quickly get a ride, for example, to Mars than to just to low Earth orbit. But I could see lunar rovers, lunar payloads becoming available as a low-cost option much more quickly, because I think of the number of commercial entities that are going to be able to get to the moon sooner.
Okay, thank you. Ravi, if you don't have something to add, I will ask Prunariu, because for sure Mr. Prunariu wants to add something on this question.
Yeah, I don't. I'll just mention that I only have time for one more question, and then I do need to leave.
Okay, Mr.
Okay. You know, there are so many questions, so many problems. So we need specialists. We need to prepare the new generation of specialists for these new endeavors. We take some measures even now. Right now, I'm on the top of a mountain in Romania, Marișel Mountain, where we organize from 6 years training for educators. Educators who will educate the children in the schools with respect to the outer space. The Jezero program, it's a project of the European Space Agency, and we have the Romanian branch here. Its purpose is to educate the educators, and we do it. We have some teachers, some professors, and we start the lessons today, this afternoon. After we finish, I continue with them. And we try to involve as much people as possible, as you do as well. NASA has tremendous programs, projects, contests everywhere. We try to organize same thing at the level of our country and to stimulate people to take part in space exploration. Thank you.
Okay, Gabi, you put that question, but I don't want to let Heather with no questions. Heather, or comments, please. Unmute.
Yeah, I'm unmuted, moving fast. And let me just say, I know we have a few questions that will still be coming, so hopefully I can get those to you, because I know you have to go. My quick question was the challenges that you foresee in getting the samples back. I know I've been reading a little bit in the news about it's a for sure thing, but maybe, and we're working on it. And I was surprised to hear about, you know, the 11 years still. That seems so far in the future that we have to wait for these samples. But I'm just curious about the challenges that when thinking about it and putting it all together that that you foresaw.
Okay.
I can start, and then if Ravi wants to add anything, so one of the just logistically, right? Where does Perseverance put these samples so that the next rover, we call it a fetch rover, can come get them back to the vehicle? There's a lot of just interfaces that have been challenging because Perseverance was tightly tied to the heritage design of the Curiosity rover, which is what allowed the cost to be controllable, essentially. So it means that the onus is on the next vehicle to be able to find and pick up those samples and get them back off the surface and then get them to Earth. So I think a lot of the time is giving both all the taxpayers an opportunity to say, yea, verily, this is important enough for us to fund as a project, as 2 more projects. So that's part of maybe the timeline or the delay. And then the second was just, I think, working out, a second main one was working out the interfaces for these vehicles. We're also doing it internationally, as we talked about. This is not, you know, Perseverance was a NASA mission with a very international, with some international contributors and a very international science community. But the bulk of the engineering and the hardware was American. That's not going to be the case for the next 2 missions, where I know ESA and Russia are very big contributors, and there are many others, but I haven't looked at it in a while and don't keep look at it every day to remember.
Yeah.
So that international collaboration also means that the communication and the interface, working it out, you know, we're not in charge and control of everything and can drive it or slow it down. You know, we have to do that all in partnership with other organizations. So yeah, so I think just when you think about building 2 additional projects, that time horizon actually seems kind of short to me, but we want to make sure we don't lose momentum while we have it. So Ravi, I don't know if you have any other thoughts on that.
Yeah, before to close, Erisa and Ravi, you remember Gabi Gulsan, because Gabi Gulsan, many years she was the host of the conference in Capitava. Gabi, I don't want to say that I'm sad with you. So any comments, any words you want to address? I know you have a questions, but you can write that question.
Of course. All my questions were answered, actually. Most of them, I'm honored to be in direct connection, still on Earth with all these great people. So just appreciate so much what you're doing especially for the young children and especially for the education. This is the education, I believe personally, that is the key to change everything and to move forward. So once again, thank you. I don't want to take you more time, but I'm honored and happy.
Okay, as you see, I have a nice short movie behind me. It's just the movie was made with a drone by Atlantykron person, and this is a new beach of Atlantykron. I want to make you jealous because we have a nice water and nice beach. And not so many people, as you see, so it's just for us. But we prepare for the next year. Maybe you change your mind and you want to come back to Romania, to come to Romania, not to back. Okay, we almost closed. Any final words, please? Erisa, Ravi, Alexandru, Dorin, 2-3 minutes more.
Greetings to everyone. I'm very sorry that we can't meet in person, but I'm very happy to see you on the screen.
Yeah,
and on Mars, Dorin.
That's right.
Yeah, very happy to see you on Mars.
I like the helicopter.
And thank you for being here, and thank you for inspiring us and youth around the globe. I know the youth around the world will continue to watch this presentation and hopefully be inspired to join the mission as well.
Thank you.
Don't forget, maybe for the next mission you have for Mars, you need to have the big 3D printer, and these 2 young guys can give you for free. Just, you know, to have Romania on the list.
Yeah, Paul, thanks for putting the links for your project in the chat. I pulled it up so I can take a look at it, but I'm excited for your project. That's very cool. I have one question for you. How much flight time do you get on your sounding rocket test?
Me?
Either one of you, sorry.
Radu, if you can answer that.
Yes, can you hear me? It's fine?
Yes.
Okay, basically we have only 3 minutes of milligravity. And yes, this is also a challenge that we had to tune the process that we can do something meaningful from a scientific perspective in that short time. So yes, 3 minutes of milligravity, and the whole flight, the ascent is like 7 or 8 minutes. And then we wait for the rocket to come back.
Okay, well, best of luck on your flight. I hope it's a great success.
Thank you very much.
Thank you for having us again this year. Like Ravi said, it's always a joy to get to hear from you guys as well as part of our international community. So thank you and good luck.
Thank you very much. Yes, thank you all of you for being with Atlantykron. Bună seara, Atlantykron. It's evening in Romania, and this is the words I said for 30 years. Thank you and hope to see you soon. La revedere.
Thank you, everybody. La revedere. Bye. Thank you.
Mihai, poate pui, te rog, filmulețul cu intro-ul nostru.
Îl închid normal, da?
Yes, of course.
Okay, great to see everybody.
Yeah.
Yeah, I love seeing everyone's faces on here. Great. Okay, we'll be preparing for the next show coming up here. Enjoy. Super, super.
Okay. E regulă, mai avem câteva minute până la următoarea, da?
Ok.
Da, și intrăm acum cu Teo, da? Avem alea două paralel.
Da.
Bine.